Here in this tutorial, we're going to use %C to represent characters on the screen. But remember that we've learned that characters are stored using an ASCII character representation, or a Unicode representation is really how they're stored today. But we talked about in a previous tutorial that the integer values 0 through 127 are printable English alphabet ASCII characters, and what we're working with then in these examples are those printable characters, and the ASCII table will show us how they're stored in memory. All right, so the %C is going to say, take that expression, whatever it is, that binary expression, and convert it to a character. We'll use characters that we can display on the screen. Right. To remind you then of the ASCII table, we'll go with an example where we're going to work with a capital letter A. And so let's take a look here. The capital letter A has a decimal representation of 6.5. It has a hexadecimal representation of 4.1, or if so hexadecimal is base 16, and then base 8 octal, we would see 101 being interpreted as its representation. Right. What we want to do is to show how to display the letter A. Let's take a look then at code blocks. Right, at this example. Right, so I've declared a variable of type char, so its data type is char. The name of the variable is cval, and I've stored the character A in it. Remember, I have to put these single quotes around the A in order for this to know it's a character. Right. And now to print out what's stored in A's memory, or sorry, cval's memory. Right, I've got this printf statement here, then saying I've got this label here so that my output is labeled, I know what I'm reading. But here's the %C. The %C says this is a placeholder for an expression, right? This first expression in the list here, right? Cval, it says to take what's stored in its memory, remember that's binary, and convert it to something, the ASCII representation, the character representation. So when we run this, right, we will see then the capital letter A, the character representation, coming up on the screen, simply because we use the %C. It tells it how to interpret the data and how to format it. All right, now let's go back here, right, and look at this example. We can have printf display this in the other representations, right, because we said the character representation is the capital letter A, but because ASCII is a binary encoding, right, it tells it how to encode that data in memory. We could also get this to print out with a decimal representation, the octal, or the hexadecimal representation as well, too. So let me just grab this code so I don't have to retype. And let's minimize this and let's add this to our program. All right. And I wanted the words character here. Right, so I've got these labels here so that we'll know then whether we have the character interpretation. So remember, %C says to take what's in memory and then show that as a character. %D says show it in base 10. %O, so that's a smaller case O, says to present that in octal. And then %X says to display it in hexadecimal. Let's build and run. And sorry, I should have taken that tab out up above, so that's a little more readable. Let me remove that so this all lines up nicely. All right, so the character representation. The %C says to format this and display it as a character. %D says to display it as a base 10 integer. Right? Decimals base 10 integer. %O octal, right? And %X hexadecimal, right? So you can see then that corresponds to the values in the ASCII chart. You go back and then check that ASCII chart as well, right? And similarly, we can display multiple characters in a string, right? You can experiment with putting multiple %Cs in there as well to have multiple characters popping up. But the really important point of this is that we can see then this specifier tells us how to interpret the data. That there are many ways, especially with characters then, that we can display the data stored in memory. All right, that's it for characters.